questions? First one, e to the 2x plus tan x, or tan 2x, you're finding y prime. This is a chain rule problem. The derivative of e to the 2x is e to the 2x times 2, derivative of the guts, plus the derivative of what's the derivative of tangent? Secant squared. So we get secant squared 2x times 2, again, d guts. So you have to remember to multiply by the derivative of your argument. That's chain rule. All right, so now y prime of pi would be 2e to the 2 pi plus 2 secant squared 2 pi. Well, cosine of 2 pi is what? 1. So secant of 2 pi is 1, and secant squared is 1, right? So this is just equal to 2e to the 2 pi. All right, any questions on that? Okay, moving on. If the acceleration of a particle is given by a of t equals 2e to the t, and at t equals 1, the velocity is 2, what is the velocity at 0? So there's two approaches to this. I like to do definite integrals. Some people like to just do an antiderivative of plus c, and then plug in the point, solve for c, and then plug in the next point into your new velocity function. That's fine, and that when it's a no calculator question, you should be able to do it either way just fine. As a calculator question, you're going to have to do the definite integral way. So something to get used to. So for this, what I would do is I would say, hey, the definite integral from 0 to 1, because those are the two input values we're given, of 2e to the t dt equals, so, and you know what, I should write this up. Definite integral 0 to 1 of a of t equals v of 1 minus v of 0. So whatever we get, it's equal to v of 1 minus v of 0. So v of 0, and we've talked about this, so it's kind of backwards. We usually say ending value equals starting value plus the net change. This is your net change. Now we're kind of doing it backwards because we know the end and we want it to start. So our starting value equals our ending value minus the net change. Just so you know where I'm kind of approaching a definite integral from. All right. So anyway, so I'm just going to find this definite integral first. So antiderivative of 2e to the t is 2e to the t. 2e to the t from 0 to 1. So you get 2e to the first minus 2e to the 0. So that's the value of this is the value of that integral. So then what is v of 0? It's v of 1, which is 2 minus this. I got to expand. So v of 0 equals 2 minus 2e minus 2. So I get 4 minus 2e. Did I do my math right? Okay. Mm-hmm. All right. All right. That's kind of a convoluted way to do it, though. And in all honesty, an antiderivative for this with a plus c would probably be faster and easier. Yeah, that's fine. That's fine. That's fine. All right. Okay. Next one, implicit with product rule. Think of this as 3x times y. What's the derivative of 3x? 3 times y plus 3x. What's the derivative of y? dy dx. What's the derivative of 2y squared? 4y dy dx. Derivative of 5? 0. Plug in your point right away, right? X is 1, y is 1, so much easier. So dy dx at 1, 1 is, so it would be negative 3 over 7. So implicit differentiation with product rule. Yeah, Keegan.
Can you explain how you got to the last time?
Oh, I add those together, you get 7. And subtract the 3 and divide by 7? Alright, moving on. Ooh, fundamental theorem of calculus part 1, FTC part 1, right? When you have a derivative of an integral with variables in your limits, you end up with, you plug in the top limit times the derivative of the top limit minus plug in the bottom limit times the derivative of the bottom limit. So you end up with 2 over t minus 1 over t, which is 1 over t. Do you not have your sheet?
No, I do, but I got it.
That's okay. If you do it, this is your review, so you do what you need to do, right? Okay. Any questions? FTC part 1. As soon as you see variables in the limits, check. Is there a derivative in front? Yes, then it's FTC part 1. All right. Faith, if you want to tilt your desk, you're welcome to do that if it's easier to see. You're kind of facing backwards right now. All right. This is just a straight up integral. So what does this equal? X cubed. What's the antiderivative of cosine? Sine. So this, because there's a minus here, be minus sine. There's not much to that one. Do it and you're done. You like that one? They should all be like that?
Yeah, they should all be like that.
All right, the next one requires what? U sub. So, U sub, U is x squared plus 1, du, 2x dx, 1 half du, x dx. All right, so when we rewrite this, this becomes 1 half times 1 over u du. You want to change your limits to match your new variable, right? So if x is negative 1, plug a negative 1 in for x, and you get u equals 2. If x is 2, plug in a 2 for x, and you get u equals 5. So you end up with 1 half ln absolute u from 2 to 5, which you really don't need the absolute value. ln 5 minus ln 2. I don't know how they wrote it. Did they write it as 5 halves?
Yeah.
Okay. Remember, when you're subtracting logs, you divide the arguments. Yes, Ryan?
I have a question not really related to this problem.
Okay.
On the AP test, are there 4 or are there 5 multiple choice options?
Good question. Up until 3 years ago, there were 5. 3 years ago, they changed it to only be 4. Yeah. Also, up until 10 years ago, they used to subtract a quarter point for every answer you got wrong. Yeah. And they stopped doing that 10 years ago.
Wait.
Yeah.
Isn't that the same as arctangent?
No, because there's an X on top.
Oh.
If there's a number on top, yes, it's arctan.
Okay.
Yes. Yes.
Can I just do that with x's instead of doing the u limits?
Then you have to convert back.
Yeah.
Yes, but if you're doing it, yes, if it's a multiple choice, yeah, nobody cares. It's fine.
Okay.
If it's a free response and you write this equals this and you haven't changed your limits, you're going to lose a point.
Oh, okay.
So, yeah. All right. Okay, for what values is this function concave up? How do we know when a function is concave up? What do we use? Second derivative. So, we find f prime. Then we find f double prime. And we set f double prime equal to 0 to find the critical numbers for our f double prime. We get 1/6. So we make an f double prime sign line. And if we plug in like x equals 0, we get a negative. If we plug in x equals 10, we get a positive. We are concave down, concave up. So we are concave up for all x is greater than 1/6. So like 1/6 to infinity, or however they wrote the answer. Okay. All right. Any questions on that one? Equation of the tangent line. We need 2 things. What 2 things do we need? Point and a slope. Point. we get from our original function. So we have to find y of pi fourths. So we have the tan squared of 3 pi fourths. What's the tangent of pi fourths? No. What's the tangent of pi fourths? 1. Now, we're at 3 pi fourths, which is -1, right? But does it matter?
I guess not.
No, because we're squaring it, right? But you ultimately are. So anyway, yes. So either way, this is 1. So our point is pi fourths 1. All students take calculus. Tangent is positive first and third. Yeah. All right. So now we do the slope. So we need y prime. Oh, before we do y prime, this is a tangent squared. Let's rewrite our function in a better format. Right, whenever you have a trig function to a power, you should always put the power on the outside because it helps you see chain rule better, right? So our y prime would be 2 times tan 3x to the first times the derivative of the guts, which are tan 3x, which would be secant squared 3x times 3 d guts. It's okay, Jennifer. All right, so now we need y prime at pi fourths. Lots of trig. So we've already established that the tangent of 3 pi fourths is
Oh yeah, -1.
-1. Okay. When you're doing secant, so when you're doing the cosine of pi fourths, most people just say the cosine of pi fourths is root 2 over 2, right? Root 2 over 2. When you're doing it with secant, I like to think of the cosine instead of root 2 over 2. I like to think of it as 1 over root 2, the unrationalized form, because then you can flip it easier, right? So cosine of pi fourths is 1 over root 2, so secant of pi fourths is root 2. So regardless positive or negative, we're going to square it, so we end up with 2. So our derivative is -12, and we end up with y minus 1 equals -12 times x minus 5. Oh, did they write it like this?
No, they wrote it.
They did a whole bunch of, okay. So -12x, -12 cancel, you get plus 3 pi, and then you can add the 1, plus 1. That would be solved for y. Did they put the x on the side?
No.
No?
It was y equals.
Okay. That's all right. All right. Ooh. What do you have to do for this one?
FTC.
Okay, well, yeah, it's a definite integral, but apart from FTC part 2, you have to do U sub in order to do it, right? Okay. Okay, so your U, 2 minus cosine x, du. Ooh, what is the derivative of cosine? Negative sine. So the derivative of 2 minus cosine x is positive sine x, right? So you end up with the integral of e to the u du, and if x is 0, cosine of 0 is 1, so you get 2 minus 1, which is 1. If x is pi halves, cosine of pi halves is 0, so you get 2 minus 0, which is 2. So you end up with e to the u from 1 to 2, so you get e squared minus e. All right, any questions on this one? Moving on, last one, average value. Use your average value formula that you all know so well. F sub ab 1 over b minus a times the integral from a to b of whatever you want the average of, which in this case is -1 over x squared. So I'm going to write it like this. Okay, so when you anti-differentiate this, you do a power rule. So you end up, since you get x to the negative first divided by negative 1, you end up with positive 1 over x, right? So this guy, this is just 2, right? All right, 2 times, so this would be 1 over x, whoops, I'm used to writing 2. 1 over x from 1 half to 1. So you get 2 times 1 minus 2, or negative 2. All right, that is yesterday's problems. I am going to pause